In the previous question, we were looking for the location of the girl, which is labeled as FC on our beam, on our seesaw, where she would have to sit to keep the thing in equilibrium, to keep it from rotating. And I made the point in the previous lesson that you could actually choose any pivot point you like, provided you know the values of the other forces. Now, because it's in static equilibrium, it means it's not rotating and not accelerating. Those two things have to be true. If it's not rotating, that means it's not rotating about any point you choose, not just the actual fulcrum, which was originally a rock in the middle of this thing right at this location. So I can choose any pivot point I like. So just to make that point, I'm going to redo this question where I choose the beginning of this as the pivot point. So instead of having the pivot point in the middle like we did in the previous question, I'm going to slide it over to here, and that's going to be my pivot point. And I'm going to do the same thing. The sum of all the torques from that pivot point that cause it to go clockwise are going to be equal to the sum of all the torques counterclockwise. Same condition for rotation. I just have to watch my distances. They're going to be different now because I've got a different pivot point. So what forces are causing it to spin clockwise? Well, FC certainly is. There's the nail through the board. Imagine that's like a little hinge on the board. If I tug on a string over here, it's going to cause it to spin this way in a clockwise direction about that little hinge there. Same with FB, clockwise. F up is going to hold it and try and spin it the other way. So 2 clockwise torques, 1 counterclockwise torque. Let's set it up. FC times, now we want the distance, the perpendicular distance to the pivot point. Well, my pivot point's over on the far right. We're trying to figure out that distance. So it's x. I want to figure out what x is. FB is also a clockwise torque. And FB is a full 6 meters away from my new pivot point. What about my upward force? Okay, I've got my upward force. How far away is it from the pivot point? It's only 3 meters. It's at the halfway point. So there's my equation. Now let's start filling in our values. FC is the mass of the girl. Now the mass of the girl was 25 kilograms times 9.8, because we want a force, times x, plus. Now on this side it was the mass of the boy, the smaller boy. Now he was 35 kilograms times 9.8. And we want the distance to be 6. Now my upward force, remember all the forces down have to equal my upward force. So force A plus force C plus force B, when I add them all together, equals my upward force. We know that because my net force is 0. The whole system is not accelerating. And when we did that in the previous question, we had an upward force of 1,029 newtons. So we know the value of F up. 1,029, and we want to multiply that by 3. So if I take this and solve it for x, I end up getting x is 4.2 meters from my pivot point. So from the left-hand side. So to the right from the left-hand side. Now if we want, we can say how far it is from the center. Depends on the wording of the question. Well, if the center's already 3 meters away and my entire value for x is 4.2, I simply have to subtract. 4.2 meters minus half the board still gives me the same answer I had before, 1.2 meters to the right of the center.